All right, in this lesson, we are going to start talking about accuracy, precision, and error. Accurate, precision, and error. So we're going to be talking about some significant digits to begin with, but we're going to do a little bit of defining here. So we're going to define what accuracy means. It is going to be how close a measured value is to the true value. And then precision, how consistent are you with those results? Okay, so for our significant digits, they are an indicator of the degree of precision of a measurement. Okay, so we have a couple of different numbers. We're going to kind of define and talk about what significant digits are. And it's going to be a little bit different from when we have whole numbers compared to decimals. So with whole numbers, here's two steps that it's going to take to kind of count out our significant digits. So we're going to start with the leftmost non-zero. So on regular whole numbers, it's going to be basically the number all the way to the left. And then we're going to count how many digits to the rightmost non-zero. So start left, count right until you run out of zero, or until you get to the zeros, basically. So on this one in particular, we start on the left, and there are no other values to the right of the two. So we have one significant digit. Okay. And then here we start on the left. We don't have any zeros after it, so it's just 2. So you have 2 significant digits. All right. And then if we go to the third one, we have 1, 2, 3, and then we stop after that because it's zeros after that. We're only counting the non-zeros. So we have 3 significant digits. All right, and then here we have 2005. So we start with the left. We actually have to count the zeros here because that's your rightmost non-zero. So all 4 of them are significant. Okay, and then here, same thing, start on the left, count. We don't have any zeros at the end. So we have 4 significant digits. And then the last one is we have 2 numbers before we get to the zeros. So 2 significant digits. Okay. All right, so the decimals are going to be kind of similar, but not perfectly similar. So to determine your significant digits on decimals, we are going to, first thing is we're going to start with, again, your leftmost non-zero. Okay, so we're going to start on the left, leftmost non-zero. And then the second thing is, so we would start leftmost non-zero, and we'll get to those. And then after that, we're going to then count through all digits to the right. Because on a decimal, you wouldn't keep going most likely with the zeros. So you wouldn't have something like 12,000. If it was a decimal, you would just have stopped at the last digit. Okay, so number of significant digits here. This is our leftmost, and there's nothing after it. So 1 significant digit. And then here, 2. And then all the numbers after it. So this would be like a rounding thing. So you specifically rounded to that, even though it is a 0. So that's the only time that you'd probably keep going with zeros is because you were rounding something. But that is going to be 2 significant digits. All right, and then we get to 1.2. Sorry. Try that again. 1.2. It does have a 0, so we're really just starting at the 1, and there's 3 total. So 3 significant digits. And then here, we're going to start with our leftmost, which is there. And so there's 4 numbers after it. So 4 significant digits. And then leftmost, that's only 1. And the last one. We are sitting here. So there's our leftmost, 3 total digits after. So 3 significant digits. Okay. So that lesson was involving significant digits. There's a difference between whole numbers and decimals. And so those are the properties and the rules associated with it.